Hi, Liana, how are you? Okay, hear me?
Yeah.
Okay. We will continue, okay? And then last time we have the Unit 1, Lecture 1, the create development. So talking about creativity and project development. Now we are going into the Unit 2 that will be on data and information, okay? And one thing I need to let you know is that you must study it, okay? Right now, you must study it. We will go unit 1, 2, 3, 4, 5. Keep doing that. Probably we will finish the whole APCSP material before April, okay? The whole material will finish before April. So you will study at least once. And then in April, you work on those problem set. When we will review the problem set, and then you would review it for the second time. Is that okay so far? You know our plan?
Yeah.
Okay, so this is the plan to study this course, okay? So from now to before April will be at least to study the material once. And then in April, we will study the second time, okay? And then the Thursday part, we will keep doing the project until you finish all the components for Unit 5. And then we will start to have you to work on the project, okay? Okay,
Okay.
that's the plan. Any question for your school?
Mm, no, not yet.
No? Okay. If you have question, let me know, okay? So we'll get started for Unit 2 data. So Unit 1, we talk about what is innovation, what is project, what is teamwork, right? Those issues regarding development, product development, and the creative development. Unit 2, we move on to data and information. What is data? What is information? Okay, these are the Unit 2. So first, we will have 3 lectures. So lecture 2, 3, 4, 3 weeks on Unit 2, okay? The Unit 1, only 1 week. This one, we have 3 weeks. So Unit 2, lecture 2, the first lecture is data type, okay? So data type, first you need to know about what is data. Okay, so data is one of the big idea in the big idea for APCSP. So 7 big idea is, let me repeat one more time, it's a topic, okay? Creativity, abstraction, data, algorithm, programming, internet, and global impact. Okay, these are the 7 big idea. Review one more time. You need to remember them. Okay. And then this Unit 2 is making up about 22%, about 1/5 of the total AP exam. So that would be 20 problems. Okay. And then data. Before we do anything, you need to know about what is data. Okay. So data is a collection of facts. Collection of facts. You can collect data from all sort of medium, okay? And from lab experiment, and then from sensor, from photo. So let's assume that you have a test tube, and then you have chemistry, you have some solution, and you reading how many ml are there. This is physical material, but when you read out the data, it's 55 ml. This is a data. Is that okay?
Uh,
So this one is a whole thing, this is the entity, and you read the data is like that. Or you read another data that's the color is green, then the green color that's actually the data. Data green color is the data. Okay. And then you may actually sense it by smell. It actually is a little bit stinky. Then the stinky smell, that's another data. So this quantity, color, or smell, or anything describing the material is data. And we keep collecting data to do analysis to see what happened to the chemical reaction. Okay, so data analysis is very important for any science or business. Anything is very important because you're collecting data from the experiment. and then you compare, and then you do scientific reasoning. You believe that you are setting up a scientific method to do measurement, to do experiment, and then you come up with some sort of hypothesis, and then you actually test the hypothesis to be true or not true, or you modify the model, and then you think about a different way to analyze data. That's whole thing is called data analysis. So, but before you can do data analysis, you need to collect data. Okay, so data is actually stored in variables. So your Python language, you have A equals 3, that's the data. S equal a string of green, that's a data. And actually, you may have a D equals 3.4, that's actually a piece of data. So data being stored in different kind of variable. That can be integer variable, can be double value variable, can be floating point variable, can be Boolean variable, can be string variable, okay? All kind of variables. And then data can be digital or analog. Digital or analog. So basically, if you have the tube, you try to read the bottom of the solution. You read it as 55.1234, whatever Bitcoin ML. That is analog. Because it is not digital. It's not like 0 or 1. It's not. Actually, it's a continuous value. What is the value, we don't know. We just sampled it. So it can be 55.2, can be 55.1, depending on your reading. And those kind of physical data, those kind of physical data, we call it analog data. And when we store in computer, we store it in digital format, using the number of bits to represent it. Is that okay so far?
Yeah.
So basically, you need to know what is data and what is the data being stored in the computer. You also need to know about what is digital compute data, what is the analog data. Okay, this is related to data. So first thing is, if we store it in digital data, you will have binary bit, binary digit. So bit is binary digit. So you have BIT, binary digit. So bit is coming from here. Is okay?
Yeah.
And it can be 0 or 1. So one single bit can be 0 or 1. And in reality, it's actually when you are using your computer, it actually is 0 volt. 0 volt electricity, we call it 0. 5 volt. 5 volt for high voltage, we call it 1. So in the electronic computer, the computer that you are storing has low voltage and high voltage. And its real signal is in electricity format, using the voltage to represent it. Is that okay so far?
Yeah.
But when you store in your text file, it's 0 or 1, okay? It's a binary data, okay? So that becomes digital data. So these are bits. And starting from bits, you start to develop another idea called number system. Number system. So you need to know about what is a number system. So what is a number system? Let's look at it. So when you have a number that is 357, and then is 357 equal to 3 times 10 to the power 2 plus 5 times 10 to the power 1 plus 7 times 10 to the power 0. 10 to the power 0 is 1, okay? So this is actually, we call it a number system. So this one, we call it hundreds place. This one, we call it tens place. This one we call it ones place. So you have 3 digits 100 place, 10th place, and 1st place. So that's a place. This one is a place. And then 3 is the value and the place. Is that okay so far? 3 is the value of the place. Okay? So this one, we call it a decimal system, base 10 system. That's the number we usually use. So if you change it to binary, it's actually 0 times 2 to the power 2 plus 1 times 2 to the power 1 plus 1 times 2 to the power 0. This is 0, 1, 1. This one means 3 in decimal. And it's binary in binary number, 0, 1, 1 in binary number. Okay, this actually is a number system use base 2. Okay. Now let me show you something. One moment, okay? Okay. Now you can see me. You see my head?
Yeah.
So this one I have 5 fingers. So using this 5 finger, what kind of number I can represent?
Like
1, 1,
1
2,
to 5.
3, 4, 5. That's it.
Well,
Can you represent other number?
not anything higher than 5. Well,
So that's 6. If this one all close is actually 0. Okay. And then I open my sum. This one's 1. And then I put my index finger and then close my sum. This one is 2. So 1, 2, 3, 4, 5, 6, 7. 1, 1, 1 is 7. 8, 9, 10, 11, 12, 13, 14. 14 is this. What am I doing? So I can come to 31. So basically I have 5 fingers. I have 5 fingers. Given these 5 fingers, this 0 or 1, this is 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 0 or 1. So I'm using binary system. I have 5 bits. Each finger represent 1 bit. Open means 1, close means 0, and then I can counting from 0 up to 2 to the power 5 minus 1, totally 32 numbers. From 0 to 31, totally 32 numbers. Does that make sense?
Yeah.
So one hand, one palm, how many number I can count? I can actually count the 32 numbers. So give me 2, let's see. So let's look at this one. So I have 2 hands. So how many number can I count? So it's a 2 to the power 10 minus 1. It's actually totally can count from 0 to 1023. So it's a 1024 number that I can count. More than 1,000 number that I can count using two two palms, two hands. Is that okay?
Yeah.
That is binary numbers. That is the binary number we talk about. And my hand is the hardware. Okay. And then the way that I count it is called software. Is that okay? And we use a binary system. I'm using binary system. Is that okay so far?
Yeah.
So that's actually base is 2. Okay? The base number base is 2. So decimal system use base 10. And then binary system use base 2. Okay. And then your computer are using all binary system. Your computer system's machine code is all binary system, all represented by 0 and 1. They call about how many bits are there. Okay. So you have base 2, base 10, 2, base 10, base 8, and base 16. Base 10 will be 0 to 9. Base 2 is 0 and 1. Base 8 is 0, 1, 2, 3, 7, 4, 5, 6, 7. Base 16 is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Okay? So that's
Okay.
right here we have a 3,200, 0, and 7. It's 3 times 1,000 plus 2 times 100 times 0 times 10 plus 7 times 1. You end up with 300. This is okay? So 3, we call it is a thousandths place. The value is 3. 2, we call it hundredths place. The value is 2. Is that okay so far?
Yeah.
It's base 10. Okay. So then actually when you evaluate the value, you really use the polynomial evaluation. So this one is original 2x squared plus 4 times x plus 7. And then your x equals 10, you get the base 10 value as polynomial evaluation. Is that okay so far?
Yeah.
That's the number you have for base 10 value, okay? Then binary, you will use a 0 and 1 system. So it's the 1 times 2 to the power 5 for 32. 0 times 2 to the power 4 for 16, something like that. Okay, you have the weight or place. So it's 32's place, 16's place, 8's place, 4's place, 2's place, and 1's place. And the value is 101101. Okay, this is base 2 number. Any questions so far?
No.
No? Okay, so your electronic system is all based on this binary, and each number 0 or 1, we call it a bits. And bits we explained it before, it's called a binary digit. Okay, now next one. Next one is byte. So when you have an ABC, the factor A is stored as 0, I'm sorry, it's actually 0, 1, 0, 0, and then 0, 0, 0, 1. It's actually 4, 1. It's a hexadecimal 4, 1. It's stored as A, and we call it a symbol, and it's A bit. Every A bit, it represents a symbol, and that symbol, we call it a byte. Okay, a byte. So you say that I'm buying a hard disk of 2 terabyte. This B is byte, B-Y-T-E-S. Is that okay so far?
Yeah.
So bit is a single bit. Byte is 1 byte is 8 bits. Okay. So let's look at the Amazon then. And if I say I want to say 1 terabyte SSD, solid state hard drive. Here you will see 1 terabyte. 1 terabyte. That means 1 times 10 to the power 12 byte. That's actually 1 terabyte. So you need to know about 1 K byte. K is kilo. You know kilo, right?
Yeah.
So kilo is 10 to the power 3. Okay. Then you would have 1 megabyte. That's 10 to the power 6, 1 million byte. Okay. And then we have 1 gigabyte. That's 10 to the power 9. Right. And then next one is terabyte, TB, terabyte, terabyte is 10 to the power 12. That's the number of byte you have. So right here you say that this 132 bucks is 1 terabyte hard drive. That is the 1 terabyte hard drive. That's the total amount of the data that you can store using the number of byte to measure it. Is okay?
Yeah.
So why we call it a byte? It's actually bits, right? The bits is very similar to this word bytes. It's actually originally it's called BITES. So it's the same as the bytes. So the same as byte look like you're biting something, so they don't like this word. Then the computer scientists change it to BYTE to represent every 8 bit for a symbol. Okay?
Okay.
So this bytes, BYTE, originally coming from BITES, for plural of the bits. About the plural of bits actually look like biting something, so they don't like it, and then they change it to byte. Is that okay so far?
Yeah.
That's the number of bytes you have, and that's actually usually when we measure the data amount, we use byte, okay? But the kilo, mega, giga, tera, you have to remember them, okay? That's actually very important numbers. You need to remember them. A few things that you need to remember, not only that. Let me review it, okay? So let's look at the large number. So you have 1, that's actually is 10 to the power 0 time. You say 1. And then you have k is 10 to the power 3. Okay, this one is 10 to the power 3, and it also, because 2 to the power 10 is equal to 1024. It's very close to 1000. So usually 2 to the power 10, we call it 1K. We call it 1K. So 10 bits, you have 0 or 1, 0 or 1, 0 or 1, totally 10 bits. So 10 bits can represent 10 to the 2 to the power 10 number of symbols, and that is 1024 symbol. We call it 1K symbols. So 10 bits, we can also call it 1K bits. Is that okay?
Yeah.
It is not exactly the same as 1000, but it's actually 1024. It's actually very close. So when we say the hard disk is 1 mega, it really means 1KK. It's 10 to the power 6, and it's actually 2 to the power 20. We call it not many byte, we call it a mega. Is that okay so far?
Yeah.
Okay, you need to remember this big number. Now, small number, you also need to remember them. So you have a 1. So let's assume this is a meter. Okay, meter is 1. So 1 centimeter, how many meter is 1 centimeter? 1 centimeter is how many meter? It's the 1 over 100, right?
Yeah.
100 meter. So 1 mm millimeter is 10 to the power -3. Okay, so centimilli, you need to remember. Then next one is 1 micron. This look like U, but it's not U, it's called micron. The Greek letter micron, Greek letter like M, but we call it micron. So micron, 1 micron is 10 to the power -6. Is that okay?
Yeah.
And then 1 nanometer is 10 to the power -9. So these are small numbers, very tiny numbers. 10 to the power -2, 10 to the power -3, 10 to the power -6, 10 to the power -9. You all need to remember these different numbers. So for example, right now, we are talking about 2 nanometer transistor for TSMC semiconductors. That 2 nanometer means it's actually only 2 times 10 to the power -9 meters. That's really small geometry when you build a transistor. Is that okay so far? Hello, is that okay so far?
Yeah.
So you need to remember the big number, kilo, mega, giga, tera. You also need to remember small number, centi, milli, micron, nano. Okay? At least these are the numbers you need to remember. Okay, so far okay?
Yeah.
We talk about bits and bytes and multiple bit number of bits and number of bytes. These are basic numbers that you need to remember, okay? And we are teaching you AP computer science principle. So these are basic principle for your numbers. So you have base 2, base 10 values that you need to remember. Now, next one is to convert a decimal to binary. I may have teach you before, but let's do it one more time. So let's assume that you want to convert 13 to binary. You divide 13 by 2. You got 6 remainder 1. You divide 6 by 2. You got 3 remainder 0. You divide 3 by 2. You got 1 remainder 1. This is only 1. You can no longer divide. Then once you get this value, you read from here to here. It's 1101. So this 1101 binary will be your 13 in decimal. So I can write 1101 subscript B equals 13 subscript D, or I can write 1101 subscript 2 equals 13 subscript 10. Is that okay so far?
Yeah.
So this is conversion to binary, okay? Let's try another number. So let's assume that we want to divide 57. So divide by 2, you got 28 remainder 1. Divide by 2, you got 14 remainder 0. Divide by 2, you got 7 remainder 0. Divide by 2, you got 3 remainder 1. Divide by 2, you got 1 remainder 1. So the result will be, reading from here to here is 111001. It's your binary number for 57. Is that okay so far?
Yeah.
Okay. Now, can you try 43 by yourself? Convert it to decimal up to binary value. Use pen and pencil to do it. Use the way that I teach you. You need to convert it, okay? Because in the exam, they really will test you on this. That's why we are preparing you for it. Okay? Can you do that?
Yeah.
So go ahead, do that, and let me know when you got the result, okay? Read it for me once you are done. Let me know when you are done, okay? Take your time.
Okay. Um, 101011.
You say it's 101011.
Yeah.
So this one you divide by 16, right? It's the 2 remainder 11. So this portion is 11, this one is 2. Yes, you are correct. Okay? Another way to do it is the way that
Okay.
I'm doing it. This one you can use a hexadecimal to speed up, okay? But if we sub it by the way that I told you, let's do it again. It is 43 divided by 2. You got 21 remainder 1 divided by 2. You got 10 remainder 1 divided by 2. You got 5 remainder 0 divided by 2. You got 2 remainder 1 divided by 2. You got 1 remainder 0. So read it is 101011. Okay? Good job. Okay? So there are some way you can do it. And then next one, you actually need to know about 17, okay? Know about how to do it, okay? We teach you already. Next one is that if you reverse convert it back to the from binary to decimal, okay? From binary to decimal, you got 101011. You want to convert it back to decimal, so this one weight is 1, this one weight is 2, this one weight is 4, this one weight is 8, this one weight is 16, this one weight is 32. So you end up with 32 plus A plus 2 plus 1. And that will give you 43. Is that okay so far?
Yeah.
Okay, now you try this one. Then you try 11011. What is this value in decimal? Okay, you calculate what is this value to? You got to convert back and forth from decimal to binary, binary to decimal. You must know it. Okay, this is very important. Let me know when you are done. Okay, 11011. Later after the lecture, we are still doing the chapter review using the problem in the parents book, okay? We will still do that. So you got to work on the quizzes that we give you, okay? And then we will review that, making sure you understand the whole chapter and you actually can be answer those questions.
Um, 27.
Yeah, 27 is correct. You got 11011. This 11011, we already know it is 11. This one is 16, so you got 27. Okay, you can do that way. Okay, so these are binary to decimal, decimal to binary conversion. You got to know it, okay? And the next one is the hexadecimal. Hexadecimal is base 16, okay? So base 16 is even 16 to 2 base. It's the same when you have 57, you want to convert it to base 16, you use 16 to divide it. Okay, I do it before, so this one, I'm sorry, this one is 3 remainder 9, okay? 3 remainder 9, so that's base 16, similar to that. But you also need to know about binary to hexadecimal conversion. This table you need to remember, 0000, 4-bit binary will convert it to 1 digit in hexadecimal. So 0000 to 0111, this is 7. 1111 is F. So 0 to 10 to 15 is actually to F. This table you need to remember the conversion between binary and hexadecimal. And every 4-bit can be grouped to a hexadecimal value. Is that okay?
Yeah.
Okay. Now, if we do base 5, so let's assume that we have this is 57. Tell me 57 using base 5 to represent what would be the number. Can you do that? So you will do 57 divided by 5, get something, divide by 5, get something, divide by 5, and then read it from here to here, okay? Is that okay? Do 57 with base 5. Will the exam test you base 3, base 5? Yes, they will, okay? So you got to do this.
Okay.
Whatever I teach you in the class will be tested, okay? Will be tested. We don't teach you something that's useless. And I don't know how your teacher is going to teach you to prepare you for the exam, but I just do the way that I think is good, okay? Is that okay so far?
Yeah.
I try my best to help you to prepare for the exam. I don't know what your teacher would teach, but we try to cover as much as possible, okay? But if you do have question from your classroom, let me know, okay? I'll try to help you if I know.
212.
212. Let's do it, okay? For 57 divided by 5, you got 11 remainder 2, okay? 11 you divide by 5, you got 2 remainder 1. Yes, it's 212, okay? 212 base 5. So it's the 2 to the power 2 times 2 to 5 raised to the power 2 plus 1 times 5 raised to the power 1 plus 2 times 5 raised to the power 0. That's the base flight system. Does that make sense?
Yeah.
Okay, remember this. Okay, this is very important. I try to give you the idea and give you the idea to practice. Okay. Now you solve this problem. What is the answer of 3 base 10 plus 6 base 10 converted to base 8? So I think these two sum together is 9 base 10 converted to base 8. I told you our material is well preparing you for the exam, okay? So you can see that we do have a lot of example need you to answer in the classroom, okay? Try your best.
11 base 8.
Yes. How about base 5?
Um, um, 14.
14 base 5, yes. How about base 12? Base 12, you have only one digit, right? You have nothing else. So it's just 9 base 12, okay?
Okay.
Okay, then. This is different number, okay? It's not the same number. It's okay. Okay, so these are the number part. Now we move on to the next idea of abstraction. So abstraction is the process of reducing complexity, focus on the main ideas. So let's assume that you have a function. This function is called f of x equals a square. I don't care how you calculate a square, but I do give you the x. You need to give me a square. So I give you 2. The result would be 4. Then this is called abstraction. There is a function of square function. Is that okay?
Yeah.
As for how you write the Python code to write that abstraction, I don't care. That's actually, I just care the process of reducing complexity by focus on the main idea. So function is a functional or procedural abstraction to hiding the complexity inside the function. You use array that's a data abstraction to hide the complexity of the data into a data structure. Okay, so there are 2 types of the data abstraction. One is a procedural abstraction, that it means that using function to hide in the complexity. There's another one that's called using data structure, array, list, string, dictionary to hide the abstraction. That's called data abstraction. Is that okay so far?
Yeah.
Okay, so that's the abstraction. So procedural abstraction is that, for example, you want to do random number generation. You do random range. This one is Python code. Okay, you don't need to care about how to write the program, but you just put the 10. You will generate a number from 0 to 9. That's called random number. Okay, is that okay so far?
Yeah.
And then you may have data abstraction. You means that your name equals Smith. So name is a abstraction. Grade equal 87. Color equals 255, 123, 1110. That's actually a color. So it's a string, a grade, a color. These are all different kind of the abstraction for data. Okay. So green color means color of green color in this color space maybe means a 0, 2550, that's green. Is that okay?
Yeah.
And you don't need to remember 02550. You just need to remember it's a green color. That's called data abstraction. Okay. Blue is 00255. Red is 25500. Okay. Those are different abstraction for colors. Now, next one is the analog and bit representation. So in your real world, every day you listen to a music, you actually watch video, you actually have the TV, you have all kind of things. These different data are actually all analog, especially for the audio. I actually create this song, and it's all in audio, it's all in analog. That means that the voltage may go to 2 volt, drop down to 0.1 volt, go up to 1.8 volt, something like that. So these values are actually continuous value. But in reality, you cannot transmit this one over the internet using the analog value. Yes, you can. In the old day, you can pass the analog value, but analog value is easy to get distortion. So then they decided to quantize it, to send it like digital value using number of bits to sample it. So you sample the data and you send it, that become bits, become digital. Is that okay?
Yeah.
So you may hear the word that may have, we may use a 16-bit audio. That means your audio signal is represented by 16-bit data. Okay, but in real world, you are using voltage, so it should be a continuous value. So let's search internet. You can search 16 bits audio. Okay, so 16-bit audio is a standard digital format formerly used for CD that define the dynamic range and detail in sound files. So it actually is the sound file you represent it by 16-bit. You can also try to use a 24 bits audio. So 24-bit audio is a digital format with high bit depths. Okay. So your data, analog data being sampled with the digital value to store it. It's like this. Okay. Does that make sense?
Yeah.
The real data is the red line, and your data sample is not analog. It will be digital like the squares. Okay? That's the digital sampling. So before you get your data, you need to sample your data from audio. So for example, right now I'm talking to you. So I'm talking to you. I have this, let me show you. I have this microphone. You see my microphone, right? This is the Yeti microphone. It's a very good microphone. So they will sample it and then transmit the data to you in digital format. So this one, we call it Blue Yeti microphone. So Blue Yeti microphone is used for a lot of online teacher like me or some some presenter on internet, TV, presenter or YouTuber. Is that okay? I got this silver one. So anyway, but these different things, they will sense the data from the audio signal to digital and then send it. So it actually is used for YouTube, gaming, streaming, Discord, PC, studio sound. You see that? Is that okay?
Yeah.
So they will convert it from analog signal to digital and send it to you using USB and then send it to you. So you hear my sound through the Zoom connection, but originally it is sampled by this Blue Yeti microphone. Okay. And so you actually sample your audio or image signal and then convert it to bit. When you conversion to the bits, we call it encoding. Encoding means that you are converted to digital format. So when you are sending the image, the encoding process, we call it JPEG. You know JPEG, right? Hello? Do you know JPEG?
Yeah.
JPEG is an image or picture file you send to your friends, okay? Okay, those are, and when you sample it, you actually take a picture, okay? So now let me do it. So right now, let me use my cell phone and then I take a picture. Right? I take a picture and then let me send a picture to you using the Facebook. So it will be a digital format. Actually, in my computer, I set up to be a JPEG file. Then I send it to you. It's a JPEG file format file, send it to you. And that's because the original is actually a lot of light, blue, green, a red light. I try to use the camera to sample it. Once you sample it, it converts to digital and then send it to you. Is that okay? Does that make sense?
Yeah.
So it also is converting from the analog signal to digital and then send it to you. So this is called encoding. So when we are in the real world, we have a lot of sensors to sense audio, to sense image, to sense video, to sense numbers, to sense all kind of things. And then we take it into your computer. So your computer's data can be digital, can be analog, can be image, can be video, can be audio, can be any kind of the material. Okay, as your input or output. So that actually is all possible. Okay, but you do need to do encoding. Next one is the ASCII code. ASCII code is the code to encode your text file. To encode your symbol, your ABCD is represented by the ASCII code. Okay. A to Z represented by ASCII code. So these are the ASCII code. A is 65 decimal, 41 hexadecimal. So these are the symbols A to Z, A to D, capital and lowercase, and numbers. Each symbol will be converted to a digital format, okay? And then Chinese is more than the basic ASCII code. So you will need to use a Unicode to do it. Unicode is 2 byte or longer. So you can put more later into it. Okay, that's called ASCII code. Okay, anyway. So your image can be this time as numbers. So you send your numbers, your image as number to over the internet. So now you know what's bit. Bit is a single bit, 0 or 1. And then you have a byte. Byte is actually 8 bits. And then kilobytes is 1,000 bytes. Okay, megabyte, gigabyte, terabyte. Okay, this is unit storage. You need to know that. So far, okay.
Yeah.
And then this is file format. So you a single bit, that's 1 bit. 0 or 1. 1 byte is actually a ASCII code, maybe a A. Data field is actually say your name equals Liana. Liana is a string. So that's a data field. Object is a student. Student do have name, have age, have name, and have age, and have GPA. That's called an object. These we teach you in dictionary or in Python, right? Is that okay? And then this one is data structure. Data structure is bigger than student. It may be student array of 10 students. That's called data structure. Is that okay?
Yeah.
And then data file, it means that the whole very Christian high school's student data being put into a file. So you burn it into a hard disk. That's a data file. Then the next one is a data package. So data package means it's bigger than just a file. So the previous one is student file. Then right now you may have a package of the student plus teacher plus staff. The different file for the people in the school. That's one's the database. So that database may include people. People has the student, staff, and teacher. And also you may have the score, GPA data. You may also have the course data, each course data. You may also have the degree data. You may also have the salary data for teachers. So the whole thing about the school in data format is called data packages. So right now we are talking about data from small to big in different data organization. Is that okay so far?
Yeah.
Starting from a single bit to a byte to a data field that's actually a name, to an object that's actually a student, to a data structure that may be 10 students, to a file that can store the whole very Christian school student, to a package that included the student, teacher, and staff. And then last one is the database including everything in your very Christian high school. Does that make sense?
Yeah.
So when we talk about data, we are talking about data of different complexity. Okay?
Okay.
So you start from the bits, you do sampling, you measure your age. So you, Liana, let's assume you are 14.58 years old. Okay, I don't know how old you are, but let's assume it's a 14.5. So that 14.5 become a data field for your age being stored, right? But 14.8 converted to the low level, you may have bit, it may be 1.110.111, whatever the bit format it is, okay? And then it can become bigger and bigger in the system. So right here told you the size of the organization of the data, okay? And then you have analog representation and digital representation. We talked about it for the audio already. So you will do sampling, your audio signal, you will sample to the bits and bytes, okay? And then original data is like this, analog, and you can use a different time to sample it. We call it discrete time. And then if the number also represent the digital, we call it a digital signal. So you may have discrete time, discrete value. You may have continuous time, discrete value. You may have discrete time, continuous value, different sampling mechanism. But usually this we call it analog. This one we call it digital. Okay?
Okay.
Any question, let me know, okay? So you may have overflow error. Overflow error means that, okay, let's assume that you use a 16-bit audio, but your sound is too loud. So your 16-bit is not enough to store it, then you may overflow. So you may jump the data. You will lose the number of bits. That's called overflow. Is that okay so far?
Yeah.
when your number of bit outgrown the data structure that you have, data representation you have, you do have an overflow error, okay? Okay, and then you may have quantization error. Quantization error means that your real signal is this line, but when you do digital, you actually end up quantize it with noise because you do not have the real physical analog value for voltage. You actually got the 0, 1, 1, 1. So this whole thing right here is 1, 1, 1. Right here is 1, 1, 0. You actually chump it in a way. You create a quantization error. Is that okay so far?
Yeah.
And next one is the file type. So we finish with data. Data, you have analog digital. The next one is the file type. So after you, okay, so that data discussion is up to here, up to the data field, okay? Anything up to here, you be stored into a file, then it's your data file, okay? It's your data file. So your data file can be stored for picture, that's called JPEG, store for text file called TXT file, store for music that's called MP3, store for Word is called DOC, store for PDF for reading is called PDF file, compressed file called zip file. Is that okay so far?
Yeah.
So this one right here, you pretty much need to know every single file format. So right here, something you may not know is this TTF, you may not know. EPS, you may not know. PNG, you may not know. These are picture file. This one document file. This one WAV is a video, audio is a video file. CSV is for Excel. Okay, so these are the file format you need to know. Okay, your data is stored as a file with different format. So first one, we talk about text. So after here, we are going to talk about different type of file, including text data, and then black and white image. So it's a file of different format, okay? And then color image files, and then audio files, and then video files, and then graphic files. So these are different data type we will talk about today for different data, okay? Any questions so far?
Yeah.
So let's get started with the text file. So text file, you store your English in ASCII code. And you store your Chinese data in Unicode. And it's called text file. So when you create a text file, it's very simple. You go to your disk, you do new and text data. Okay, this one that's actually call it AA, okay? And then you open it with editor, maybe your notepad. I'm using notepad double plus, okay? So I'm going to open it with notepad double plus. So this AA file is empty right now. I'm sorry, one moment, okay? I opened the wrong. Okay, this one is the notepad double plus. Let me type in hello world. Okay, so this is hello world. I have the hello world. I save it. Okay, and I'm going to close it. So here, Let me open it, okay? Let me open it again. So this is hello world. Let me save it. Let me close it. So right now it said that 1K byte. So why is 1K byte? Because the smallest file that can have for Windows is 1K. They will allow you 1K anytime. Is that okay?
Yeah.
Now, if I new this one with Microsoft Word, I also call it AA. And then I actually type, I open the Word software. It's a PowerPoint. I'm not using this one. Let me open it. So I'm using Microsoft Word to edit the file. And right here, I also do Hello World. And I save it. And I quit. So let's see. This AA become 14 kilobyte instead of 1 kilobyte. So why this Hello World in Word is bigger than AA in Notepad? Do you know why? I both type hello world exclamation mark into there, but how comes the file that I use Word is bigger than the one I use a Notepad double plus? You know why?
Like compress.
No, it's not compression because this one you have the word. I may change the color. I may make it bigger or smaller, but in Notepad double plus, it's a text file. You cannot do that. So Word not only store the hello world, you also store what font you are using, what color you are using. Where are there those words? Is that okay? Hello, is that okay?
Yeah.
But the plain text do not have that. Your TXT file is only the text. You do not have those color with it. You open it, there's no color. You can show with color, but that's editor's color. It's not the color of the text. Is that okay so far? Okay,
Yeah.
so those are text file. We don't want to spend too much time on text file. Let's just tell you, you can store your word, everything in text file. And text file usually store a lot of string into there. And you can use your Python file to open them to read it one by one. And the file hello.txt and hello.doc is actually different size. Okay, different size. Because it store different amount of data. Next one is a black and white image. So black and white image, okay, I'm going to teach you in different way, okay? Let me see, one moment, okay? Let me try to get something from my side. One moment, okay? Let me try to get something from my side. See if I can get some data, okay? One moment, okay? Let me try to get some data. Let me see if I can get some colorful data for you. Oh, okay. This one's not good. Let me get some color one. Okay, how about this one? I've got this ASU sticker. I'm going to use it, okay? I have a scanner. So I open my scanner and I put my ASU sticker over there. I scan it, okay? So the first thing I talk about text file. Now I'm using the scanner. So I'm opening the this one called HP scanner. I do have this HP scanner. And I want to scan it. Okay, so now I want to choose image. I want to choose, let me change it to, let me use a PDF, actually using JPEG, but I'm going to change it to black and white. So it's actually black and white color. So it actually is the, let me see. This is section we were teaching black and white image. Okay, so we choose black and white right here. You see here? Hello?
Yeah.
So I'm going to, okay, I'm going to scan it. So let's scan. Okay, and I'm going to save it. So let me save it to E drive. Save it to the same location we have, okay? Let me create a new one. Let me create a new one. Let me create a new one. Let me create a new directory called data. And then let me create this one called lecture 2. Okay, and in lecture 2, let me store this one as BW image, okay? JPEG file, but it's black and white color. So let's look at the file. I try to save it, but look like it's not successful for the first time. Let me store as BW. Okay, let me restart again, okay? Let me restart again. Look like the program doesn't go through. Again, one more time. I don't know. I'm trying to use this scanner, but this scanner is not working. Let me try one more time, okay? Okay, I'll keep up. I would demonstrate some other time, okay? This one, I tried to demonstrate with my scanner, but my scanner doesn't seem to work today. Anyway, So you store your image with black and white color. So you have some text, you store it with only black and white. So let's assume that you have write something and you store one here, one here. Okay, this is one. And when those have no data, you put the 0 there. This is called black and white. Is okay so far? So black and white is one
yeah.
encoding scheme. And then the image is the graphic data that you try to capture the data. That's called image, okay? So black and white is one way you can sample your data. I'm not sure why my scanner is still not working. I'm trying to restart it. Okay, something's wrong. Something's wrong for my scanner. I still don't get it. Okay, anyway, that's actually black and white, okay? Next one is halftone. Halftone doesn't mean black and white. You actually use a different pattern to sample it. So you can use this pattern or you use this pattern or this pattern. But when you see it, it's actually a little bit coarse. It's not really fine data. It's still black and white, but they use a pattern to store your data. Let me try to see if the last year's data can be used, okay? I remember that last year I also do the same thing, so let me check if I do have the last year's data. No, that is what. Okay, lecture 2. I do have the lecture 2. So black and white, let me see black and white. Okay, I'm sorry for the scanner, but I try to give you the more better. So this is last year I scanned something in that's in black and white. So it look like this. Okay, so it's a black and white. If you go down to the detail, you can see it's actually a lot of texture for black and white only. Is okay?
Yeah.
Let's look at the halftone. Okay, let's look at halftone. So halftone is this one. Halftone is using pattern to sample it. So it's actually coming with a regular pattern of this one, coarse or fine. So halftone is like this. Okay, but if you zoom into the see the halftone, it's not black and white. It actually comes with patterns. This is a halftone image. Is that okay so far? So some region they may use one pattern, the other region they may use a different pattern. So here you use one pattern, here you use another pattern, here you use a very dense pattern, okay? So that's you use that to sample your data. Your data eventually is a bug or something. Okay, that's the same presentation we have, okay? So this is a halftone. Now, there's a halftone. Halftone is still black and white, but they do come with pattern. Next one is gray label. Gray label means it's actually only gray and white and black, but it's 0 to 255. So 1 byte format to represent your data. 0 to 255. There's only one color, but it's better than the halftone. If you look at it, it's actually a little bit fine. You can't really see what it is. It's a donut box, right?
Yeah.
Is that okay? This is black and white, okay? Let's look at the last one. Let's see, color. Color uses 3 color, red, green, blue color. So this is the color. Original color is like this. You have a box of donut, and then this is the coupon that I used last year, okay? I'm trying to use the ASU pattern, but today the scanner is not really cooperating. But this one, 3-channel, red, green, blue color is like that. Okay, that's actually, so these are the image portion we talk about possibly storing with black and white, halftone, gray level, and also color. So then next one that you need to know is the metadata. Metadata is very important. You must know about what is metadata. Okay. So metadata is data about data. So what does it mean by data about data? So you send me, let's assume that I send you a JPEG file. I send you a JPEG file, but you do not know what kind of the JPEG I'm sending. Is that black and white, or is that halftone, or is that gray level JPEG, or is color JPEG? We don't know, right? So in the header portion, in the beginning part of the file, it will tell you it's a black and white, or it actually is a color JPEG, or any kind of data. This data about the data is called metadata. So description of the file is called metadata. Is okay?
Yeah.
So description of the data is not data itself. So it's not the picture itself. It doesn't represent the picture itself. Instead, they give you the idea of what kind of data being stored in the file. So for example, this one is an image file, a JPEG file. Directory is where, file type is where, size of the file, rating of the file, the title of the file is the Golden Gate. Okay. Creator is who, location where, size of the image. This kind of data about data is called metadata. The real data is really the picture. So you should have a Bay Bridge, San Francisco Bay Bridge, something like that. That actually is the real image data. So before the image data, the JPEG file will send you the metadata. Metadata tell people what kind of file you are receiving. Is that okay? Does that make sense?
Yeah.
So the metadata included is a data about data, including the descriptive data like title, author, subject, genre, publication date, technical data like file type, is a JPEG file, or is a MPEG file, or is a MP3 file, file size, creation time, and compression scale. I use a JPEG or MPEG to compress it. Okay, those kind of things. Markup language, okay, HTML, those kind of things called metadata. Data about data is called metadata. Okay, next one is long length encoding. Long length encoding is sometimes we want to do compression. So that's actually you do have a black and white image. It's a white, black, white, black. So something like that is called, you use a black and white bitmap. This one we call it bitmap. Bitmap means that each bit representing one side of the one part of the map. Is okay?
Yeah.
But sometimes we want to compress it, so we send 3 white, two black, and 3 white. So this is called long length encoding. Long length encoding is the color with the length, color with the length. Is that okay?
Yeah.
That's called long length encoding. Okay, so your data can, but sometimes long length encoding may end up bigger than the bitmap. So depend. Okay, if your data is had too many one bit black, one bit white, one bit black, one bit white, then your long length encoding may be bigger. But if you have like 200 white, then your long length encoding will be better. Okay, so this one is a JPEG format. You convert your JPEG input to using the compression scheme. Okay, so you can compress your color image to black and white image. Okay, you can also do color image. Color image, you have RGB channel. red, green, and blue, 3 channel, and each one we call it a picture element. Picture element is also called pixel. Picture element. So it's a picture, so it's a PIC, picture EL. So become pixel. Is that okay?
Yeah.
So when we talk about pixel, we talk about number of the bytes or number of the pixel element, picture element. So each pixel element usually is one combination of RGB. So you have the red, green, blue, one unit of red, blue. It can represent the blue, may represent the red, may represent the green, may represent cyan, different color. But one RGB unit, we call it one pixel, one dot in the image, okay? And
Okay.
Fibicon is the west size, a small image, is a 16 by 16 pixel. We talked about it before. So there are two types of the color system, RGB system and CMYK system. CMYK is cyan, yellow, magenta, and black. So who use RGB? What system what computer use RGB? You know who use RGB and who use cyan, CMYK? RGB is very simple. Your monitor, your computer LCD is using RGB, your TV is using RGB, right?
Yeah.
So who use CMYK? Who use that? Who use this color model? So RGB is one color model, CMYK is another. Who use CMYK? Do you know that? You must have used it before, but you just don't know.
Printers.
Printers, yes. So when you buy printers ink is cyan, magenta, and yellow. It's a CMY and black, 4 color. It's okay?
Yeah.
You remember that now?
Yeah.
You saw this before, right? You actually, when you look at the printer is using this one, okay? HP printer, everybody uses CMYK for printer. They never use, so your monitor, anything like a light or light bulb using RGB, anything printing on ink, on paper, usually using CMYK. You know what I'm saying? Your monitor, your TV, everything that actually will go to your monitor, you will see it like a TV or like your monitor is actually an RGB system. Anything there that you print now using printer or laser printer is all CMYK. Okay? Okay. So CMYK, you have cyan plus yellow plus magenta, you make black. You mix these 3 colors together, you make black. Red, green, and blue, you mix them together, you become white. So more color make white in monitor. More color make black in printer. Does that make sense?
Yeah.
Okay. There's a CMYK and those that. Okay, whatever. We talk about it enough. Next one is audio. Audio, you may heard the word audio, speech, sound, audio, speech, sound, and music. Okay, what are the difference for these four different words? Can you tell the difference between audio, speech, sound, and music? These 4 different words. What do they really means? So first, what is sound?
Like, what you hear.
Yeah, anything you hear is called sound. So what is audio?
Transmitted sound.
No. Yeah, here I say that in a slice, but sound is anything you hear is called sound. Any sound that being recorded, you use a microphone to record it, you use a tape to record it, you use this headset to record it. Anything you record it, MP3 file, any sound that you recorded. So sound is natural. The thing that you hear is called sound. The thing that you play back in computer is called audio. Does that make sense?
Yeah.
Anything stored or recorded in computer is called audio. Okay? Any sound, any vibration, anything that you hear is called sound. So sound is natural. Sound is everywhere. Everything you can hear is sound. Audio is those kind of things being processed by computer. That's called audio. So what is speech? Speech is the audio that related with human speaking. That's called speech. Is that okay?
Yeah.
What's music? Music is the audio that's not related to speech. Anything created by instrument, by something that playback, but that's not speech. We call it music. Is that okay?
Yeah.
Okay, so these four words are very close, but you need to know the difference. Sound is anything that you hear. Audio is anything that you record. Speech is anything that's being talked by human. Music is anything created by any instrument. Okay? Next one is the frequency. So what is frequency? You have audio like this. You have audio signal like this. And what is frequency? So first thing you need to know is that you do have time domain data. Time domain data means that over the time your audio transmit like this. You have up and down, you say something is like this, okay? But you can look at its frequency domain, means that you do have a audio like this. So this one maybe is a sinusoidal low frequency signal like this. Okay, minus a small signal right here is a higher frequency being applied to here. So your audio may be represented by multiple frequency from low frequency to high frequency. So high frequency is giving you very, very sharp sound, very, very piercing sound. And then low frequency give you bass, give you very powerful but low key sound. Is that okay so far?
Yeah.
Let me play back a different things. So that's actually using the, what's this one? That's Audacity. So Audacity is a recording device. Okay, so this one is Audacity. Now you see I'm playing back Audacity. So right here I do have recording button. Okay, so I'm going to record in my sound. So I'm going to say something. Hello. Konnichiwa. How are you? I'm good. How are you? Okay. So I sample the sound like this. So this one is a time wave that I have. So this one over the time, let me see. Let me zoom it in. You can see my sound. It's sampled in this way. Is that okay so far?
Yeah.
And this whole scene we can actually we can look at the frequency domain that's using analyzer. That's plot spectrum. So my speech, high frequency over here, low frequency over here. That's the voice that I have. So usually human voice is from 20 hertz to 4,000 hertz. These are human speech. 40,000 hertz. That's a human speech. It's okay?
Yeah.
Okay, that's the low frequency and high frequency. Okay, so I'm showing you what's low frequency, high frequency. So by the way, what is 1 hertz? What does it mean by 1 hertz? So you may hear that you are using the Wi-Fi. Wi-Fi is using gigahertz, right? You may have megahertz. So what does it mean by hertz, gigahertz, megahertz? Do you know? Do you know? 1 second, 1 second per vibration per cycle is called 1 hertz. So 1 kHz means that within 1 second, the sound vibrate for 1,000 times. So 1 megahertz means within 1 second, the sound vibrate for 1 megahertz times. Is that okay so far? That's
Yeah.
what the word hertz means. So hertz is the unit for frequency. Okay, hertz is the is a unit for frequency. So you have low frequency, high frequency. Okay, let's see. Did you hear the radio before? Do you know there is a FM radio?
Yeah.
So FM radio actually usually is what? It actually usually is in the number of megahertz. Okay. And then you may also have the AM radio. AM radio usually is kHz range. Okay. So different range, they will transmit different system for communication. Okay. So AM transmit over the kHz. Okay. So let's do K-log radio station. AM. So there's a K-log. It's a religious radio station. It has the AM. So it's AM 100.3 in LA. Okay, 100.3 kHz is used for K-log radio station. Okay.
Okay.
Anyway, these are frequency. Okay, these are frequency. And frequency is a channel. We actually transmit the data by the frequency. Okay. So amplitude is when you transmit your data, how big the swing is called amplitude. Period is how long the time been going on. And then the one period time, how many period per second, that's called frequency. Wavelength is that within that one period of time, how long will the radio go? That's called wavelength. Okay, these are some idea you need to know about audio. Okay, so basically, let's assume that you are sampling your audio. Okay, your audio is like this. You sample your audio. You use the frequency, wavelength, period, or amplitude and speed to sample it. Okay, now, so frequency is how fast the data is. Now, so you need, when you try to see how many bit your data need to go, then you need to calculate your channel capacity. And your channel capacity, channel size, depending on your number of channels. So if you are stereo, you have 2 channels. And then your sampling rate, and then your time, how long you will sample. Let's assume that you have 1 minute MOOC. So 1 minute would be 60 seconds. Okay, let's assume that you will sample like 10K hertz range. So 10K hertz means that you have 10,000 hertz. So 1 second, you will sample 10 to the power 4 samples. So your 2 times 10 to the power 4 times 60 times, let's assume that you are 16 bits. You will use 2 bytes to sample it. So this one give you the file size of 1 minute music. You will end up with 240 times 10 to the power 4. It will be 2.4 megabyte for 1 minute music. So you send me, recording a 1 minute audio. If you send me by stereotype and then 16-bit data without compression, if we do not compress the data, then you would take 2.4 megabyte to transmit. Is that okay so far?
Yeah.
So how much your Wi-Fi can do? You use a Wi-Fi. How much your Wi-Fi can do? Usually maybe 100 megabits per second. Okay, 100 megabits per second. This one we call it the capacity. That's the amount of the data that you can transmit over your Wi-Fi network. But your data loading is 2.4. Okay, so this one 100 megabit per second, we can also call it your bandwidth. So bandwidth is your amount of data that you can transmit over a channel. It's 100 megabit per second. That's your bandwidth. And this 2.4 megabit byte per second, that would be times 8. That would be somewhere around maybe 19 megabit per second. That's your bit rate. That means 1 second you need to transmit 19 megabit. So 19 megabit is smaller than 100 megabit per second. So this audio is okay to be transmitted over Wi-Fi. Is that okay?
Yeah.
Knowing what I'm calculating? If you cannot trust me over your Wi-Fi, then you need to compress it. Okay, so here is calculating of the audio side. So same mechanism, you can also calculate it for the video. Okay, similar thing, you can also calculate the video. So audio, video, you also always need to calculate the bit rate. Bit rate is the real data rate that you have to transmit your audio data. And then bandwidth is your network's capability to transmit the data. Okay?
Okay.
You need to remember that, okay? This one you need to know. Next one is the video, okay? We try to finish all type of material and we are going to stop today, okay? So video is the one that you store your TV or your TV or your video, okay, or your movie, okay, your movie. So there is also a bit rate, how fast your data need to be transmitted. And if your bandwidth, your network is below that bit rate, then you need to compress the video, make it smaller files to transmit. Okay, so that's called video compression. We'll talk about compression later. Okay, right now we don't talk about compression, but you need to know what is bit rate. Aspect ratio is your 9:16. The ratio of your width and height is called aspect ratio. Is that okay?
Yeah.
The next one, resolution. You need to know about resolution. The resolution is 640 pixel by 480 pixel. That's the standard definition. High definition is 1280 times 720. Okay. Then super high definition is 1920 times 1080. Nowadays, you do have a 4K TV. 4K is even bigger than this. That's called resolution. Resolution is talking about the number of bits in your picture. Okay? Is that okay?
Yeah.
Frame rate is that your video would send a lot of pictures. So each 1 second, how many pictures you send is called frame rate. Okay? How many pictures you send over a second. Usually you need to faster than 30 frames per second before you see that the video is moving, okay? And you have interlace scanning and progressive scanning, okay? This one is the way that your TV scan your video. This one, okay, I don't want to go into the too much detail. And you have a small LCD to ultra high definition to curve high definition to 4D, 80, okay, or 4K, 8K TV. So this one, 480 pixel, 722 pixel, 720 pixel, 1080 pixel, 4K, 8K, okay? It's okay so far?
Yeah.
Different picture size and different file format, okay? You just need to know them. We will tell you when we need it, okay? Don't go into too much detail. And video playback is your YouTube will playback your video streaming, okay? So you upload your video to the website and YouTube play for other people, okay? This is called streaming. And streaming have live event, just like right now, we have a camera, we have speaker, we have the internet connecting together to do live terabyte meeting. So this Zoom technology is also one of the broadcast streaming technology. Okay?
Okay.
Okay, so that's the video. Okay, and then you need to create video. Okay, editing it, hosting it. Okay, these are different things, and this is the control room for a stage. Okay, you see that the tons of monitor and equalizers, tuning the sound. Okay, control panel, okay, whatever. This is the video editing. And then they are playback system for the YouTube, okay? Okay, last one is graphic. Graphic is similar to image but different, Okay, so graphic is something that you draw as picture. So when you take picture that's called raster based, that's pixel by pixel. Okay, when you take picture is a pixel by pixel, it's called raster based, it's a JPEG. When you use a vector, so this one is a circle, you use a vector to represent it, is smoother, it's called graphics. Okay, it's called graphic. So graphic is usually used for human art, raster based or picture usually for picture capturing. Okay. Okay.
Okay.
I think that's it for today. Okay. We introduced different kind of files, audio, video, text files, and also graphic files. We also introduced the small to big file data format. We also teach you how to convert a number system. Okay. That's it for today's data talk. Okay. Next week, we are going to talk about data compression. Okay.
Okay.
Let me know when you have question. Okay. And today we don't have time to go over the problem. We will find it when we finish Unit 2. Okay.
Okay.
Okay. Good night then. Bye bye.